Hello, what's up guys? I hope you are all doing really great. In this video, I'm going to walk you step by step through how to optimize and undervolt the Intel Core Ultra 7 265K. You may know that I've had this CPU for quite a few months, but the reason I didn't make a manual tuning video earlier is because I wanted to wait for more BIOS and microcode updates to roll out, so the platform will be more mature and stable. I didn't want to make a guide too early and then find out that things has changed dramatically. But now, after all the crucial updates are out already, I feel this is the right moment to finally share my full undervolting and optimization guide with you all. This CPU, in my opinion, is a good alternative, for example, to the Ryzen 7 9700X, because it can actually perform better in productivity workloads, so beyond gaming. It's a direct successor to the i7 14700K. I don't want to trigger Ryzen fans, but just saying, if you are more comfortable sticking with Intel, it may be a solid choice, especially now that prices have dropped and deals are pretty crazy. The 265K sits just below the flagship model of the Arrow Lake family, the 285K. Right out of the box, this chip runs noticeably cooler than previous gens, and that's all thanks to TSMC 3nm process and the improved optimization Intel brought this time around. But it can still get hot and consume more power than it really needs to. With the right undervolting, you can bring those temperatures down and save more power. And the best part is, you don't have to lose much performance. In fact, with the right tweaks, you can make it more consistent in performance while keeping it way cooler. So in this video, I'll show you exactly how I optimized mine and share 3 different profiles I built for different scenarios. I hope this is going to be really useful for you all. Before anything, I need to mention that for cooling my CPU, I'm using the Arctic Liquid Freezer 3 240mm, a pretty humble budget-friendly AIO, nothing too high-end. We'll be using Intel Xtreme Tuning Utility, or XTU for short. This is Intel official software for overclocking, undervolting, and monitoring. It's updated frequently to support the latest CPUs, including the Ultra 200 series. If you don't have it yet, you can just search for Intel XTU and download it directly from Intel's website. At the time of recording this video, the latest version is 10.0.1.31, released on the 6th of May 2025. That's the one you should use, since it has full support for Arrow Lake processors. When you open XTU for the first time, it will start in compact view, which is a simplified way to look at some metrics on the fly, and it lets you actually change P and E core ratios as well as voltage offset and benchmark your system. But it will be better to just switch to advanced view where all the detailed tuning happens, and that's what we'll be working with throughout this guide. In the advanced view, we can see several tabs. To make this guide suitable for first-timers even, let's take a quick tour to get you familiar with the layout before we start tweaking. The first tab is System Information. Here you can see details about your CPU, memory, graphics, operating system, BIOS, and so on. Pretty standard stuff, but it's handy if you want to quickly check your PC specs. Next, we have Intel Speed Optimizer. This feature will automatically optimize the CPU for you, and currently it's version 2.0, but in my opinion, this feature isn't really worth using at all. It doesn't undervolt the CPU at all. When I enable Speed Optimizer, here is what it changes for me. It raises some of the P core ratios. For example, when we have 3 or more cores active, instead of running at 52x, they'll now run at 53. It bumps the E cores up slightly from 46 to 47. It lowers the PL1 and PL2 from 250 watt down to 230 watt. And it reduces ICC max from 347 amps to 300 amps. It also decreased the cache ratio from 38x to 40x. But that's the most important part. It doesn't touch the voltage at all. There is zero undervolting happening here. All it really does is pump up multipliers and tweak the power caps. To show you why this is a problem, I ran OCCT with AVX 512, which is one of the heaviest workloads you can throw at any CPU. With the Speed Optimizer enabled, the CPU package power immediately jumped to about 225 watt, temperature shot into the sky in the mid-80s, and could even peak at 90. I also see power limit, throttling and current limit throttling indicators showing yes right away. So you can see them. Frequencies weren't steady, they bounced up and down constantly because of power limit throttling. And here is the scary part. The CPU voltage spiked to 1.488 volt. Imagine that. It's way too high for long-term safety, and I doubt it's even healthy for the CPU longevity. Sure, you might get a slightly high benchmark scores, but the trade-off is not worth it at all. You are getting more heat, more power consumption, and worse stability. That's why I strongly recommend leaving Speed Optimizer turned off for good and instead doing proper manual tuning and undervolting, which we'll go through in the next parts of this guide. The next section in XTU is Advanced Tuning, where we'll be doing all of our tweaking. But for now, I won't go deep into it as we'll look at it in a bit. Next section is the stress test, where you can run the CPU in different instruction sets like AVX2, etc. And also memory stress test for as long as you want. This is useful for checking stability within XTU. And by the way, one of my favorite features of XTU is its monitoring dashboard. You can unhide it using this arrow. It shows you temps, frequencies, power draw, throttling indicators, and more. All of that in one place. You can also detach it and keep it floating while you perform other tests. As you can see, while I was talking, the stress test log recorded for us some warnings about stating the CPU has actually been or limit throttling. But thankfully, in just a bit, we'll be done with all this. Next to stress test section is the benchmark one, which you can run to quickly compare results before and after tuning. It's not the most detailed benchmark out there, but it's useful for getting a baseline score and some data. For instance, on default, I got 12,209 marks, while with the Speed Optimizer feature, it got 12,537. So definitely a small uplift there, but at high cost. Then we have the profile section. This is where you can save your tune settings. As you can see, I actually made 3 different profiles with different purposes: Undervolt / high clocks, Undervolt, and Super Undervolt. We'll have a look at them in a bit, but I'd like to finish the tour first. We are almost done, because I need to talk about another great feature XTU has, which is a profile pairing. Here we can automatically load a specific profile when we launch a certain game or software. For example, you can assign the heaviest undervolt in some games while keeping higher clocks for workstation apps like video editing and such. You can even assign hotkeys to switch between profiles, which I'm sure will come in handy for a lot. Finally, in settings, you can enable or disable auto updates, change between dark and light themes, enable logging, and most importantly, you can enable restore tuning after reboot. This option will automatically reload your last set profile when your PC starts, so you don't have to open XTU and reapply it every time. If your system ever becomes unstable, like rebooting by itself or crashing, it won't keep looping or reapplying the profile over and over as a fail-safe feature. So once you have settled on stable settings and tested them well, I suggest enabling that. You can also adjust the Windows power plan here as well. Alright, that wraps up our XTU tour. Even though most of our tuning will be done here, there are still a few important settings we need to check in the BIOS, because unfortunately, not everything can be controlled from Windows. Some options have to be set directly at the firmware level. For motherboard, I'm using a Gigabyte AORUS Elite Xis, but don't worry at all if you have something different like from ASUS, MSI, ASRock, or BioStar. The exact location of options might change, but the principles are the same. Everything I'm showing you can be adapted to most boards. The one I'm using isn't even their highest end. It's a mid-range board, but still packs awesome features like 16+1+2 PRM power phases. It also uses a socket with RL-ILM lock mechanism, which can provide lower temps in general by up to 4 degrees Celsius according to their test. It's better than the standard one, which cold paints the CPU, as you all know. So with this one, you don't need any third-party contact frame at all. It supports up to DDR5 9500 MHz. Another cool thing is its sensor panel HDMI. So if you have, for example, an internal monitor inside the case, you can plug it into that for simplified connection. And finally, it packs some nice DIY-friendly features like the M.2 Easy Latch for screwless SSD installation and PCIe Easy Latch button for easily releasing those chunky GPUs. Overall, I'll say it covers all the key features without breaking the bank. There's also a black version if you are going for a black build, but personally speaking, I really like the ice one. And I also have the latest BIOS update installed, version F17E, released on the 9th of July of this year. And here we are now in BIOS. By default, Gigabyte chips with different profiles like Intel Default Settings Baseline, Intel Default Settings Performance. This one should be universal and the same for all boards. The exclusive ones from Gigabyte are Spec Enhance, Optimization, and Unleash. I've tested them in a previous video that you can see popping up here. And when you have any of those three ones selected, some specific features will be unlocked like CPU upgrade with max performance boost and enhanced multi-core. Personally, I don't like using these profiles. They push the CPU way too hard, cause unnecessary overheating, and increase power consumption a lot. If you don't have a very strong cooling, these presets can easily push you into thermal throttling territory. And in this latest BIOS, it seems that Gigabyte has introduced yet another boosting feature, the Ultra Turbo mode, which seems to be based on Intel 200S boost. I haven't tested it yet, so it will be interesting to do it later. So make sure you sub to the channel to find out the difference with me in the future. For now, I'll just stick to Intel Default Performance mode as my base profile, and this way everyone could follow along. Then we'll make all the adjustments manually in XTU. So here are some of the important BIOS options I've set. In advanced CPU settings, Intel Speed Shift technology enabled. This lets the CPU manage frequency and voltage transitions internally on the hardware level, instead of relying on Windows to do it, resulting in a smoother performance. So that's why I enabled that. EIST function is disabled because it dynamically reduces CPU vCore and frequency to decrease the average power consumption. Since we are doing manual tweaking, I prefer avoiding these features, not cause any conflict. Raise to Halt or RTH is enabled. This one sounds cool because it dynamically increases the CPU frequency to enter package C state faster to reduce overall power consumption. So like the CPU performs as fast as it can to enter a resting state, which sounds good to me. Energy efficient turbo is disabled. This one reduces turbo frequency for the sake of efficiency, but it can also interfere with performance. So best to turn it off. Even Intel recommends disabling it when overclocking. So I'll turn it off to not cause any kind of conflict. Now we'll get to Intel Turbo Boost technology. This one I enabled it because of course without this the CPU will stay locked at its base clock. On the 265K, that base clock is 3.9 GHz. And Turbo Boost is what lets it push above that whenever there is enough thermal and power headroom. It's basically scaling the clocks higher on lightly threaded tasks and adjusting dynamically under heavier loads. So of course, we are keeping it on. Undervolt protection is naturally going to be disabled. This is super important. If this is enabled, you won't be able to manually undervolt in XTU. You will see a little lighting symbol telling you that voltage cannot be set more in negative value than what it put it with. You can increase voltage but not decrease it. So it's crucial to have it disabled to undervolt in XTU. Some motherboards might lack the option to disable undervolt protection, unfortunately, such as B760 chipset. But on mine, and I believe all of the Z890 disabling it lets you freely undervolt in XTU. Also make sure you have Intel Innovation Platform Framework enabled for features to work such as dynamic tuning technology and such. I set my IA, AC, DC load line values from the default 78 down to 76. This basically tweaks how the CPU requests voltage under load, making it pull slightly less overall, which helps cut temps and power a bit without hurting stability. Dropping from 78 to 76 isn't a huge change, but it's the lowest I have, so I kept it this way and it works fine. So if you have that option, don't change it by quite a lot, just dial it down a little bit from the default. I kept all C-state settings enabled. This allows the CPU to reduce power when idle and in sleep mode. Switching to the Settings tab, then to I/O ports, I've disabled the iGPU to save package power since I'm using a dedicated GPU. I also disabled the LAN controller since I'm using Wi-Fi for connection, and I disabled the SATA controller since I don't have any SATA device connected. In my opinion, it's always better to disable things you don't need. This can contribute to lower stress on components like motherboard and the CPU, and the chipset as well. Now back to the OCT wicker, other things I've enabled are high memory bandwidth and low latency. I think they are Gigabyte features for RAM. As you can see, I left all of the voltage modes set on auto since we are doing the heavy tuning in XTU for voltages. But we'll still need to head into advanced voltage settings, then CPU/VRM settings, because this is where some of the most important stability settings live, especially after undervolting. Here you will find the CPU internal AC/DC load line options with those available selections: power saving, performance, turbo, and extreme. These control how aggressively the CPU requests voltage under load. Lower settings like power saving allow more drop, while higher ones try to hold voltage tighter. Then depending on your motherboard, you will also see CPU load line calibration levels, or LLC for short. On my Gigabyte board, there are 8 levels ranging from normal all the way up to ultra extreme. The principle is the same. LLC affects how much the V-core voltage drop when the CPU is fully loaded, like in heavy workstation softwares and even games. Here is the deal. Standard and normal and low allows natural voltage drop, known as V-drop. This keeps things cooler and helps with efficiency. But if your undervolt is too aggressive, it can cause crashes under heavy load. I always told you guys this in my 13 and 14 Gen CPU tuning guides. Now medium and high reduce the V-drop effect and keep voltage steadier. This does mean the CPU might run a bit hotter compared to previous levels, but it gives you much better stability in tough workloads like Cinebench or AVX trace tests. And finally, we have Turbo, Extreme, and Ultra Extreme. They are going to push voltage so aggressively that they basically almost cancel out your undervolt. You will see higher temps, higher power draw, and no efficiency benefits. Those modes aren't useless at all. They are designed for extreme overclocking scenarios like competitive benchmarking with LN2 cooling. Under LN2, you don't care about efficiency or temps because the CPU is being cooled using super high cool techniques. In that case, the only goal is to force the CPU to hold the absolute maximum voltage at all times to reach insane clock speeds for short benchmark runs. But for normal water or air cooling setups like ours, using those modes is a bad idea. They just jack up the voltage unnecessarily and hammer your temps and VRMs for no benefit. For me personally, the sweet spot is setting CPU internal AC/DC load line to performance and both DLV-RIN V-core load line calibration and current protection to the middle setting, which is high. This keeps voltage stable under load without wiping out the benefits of undervolting. It can still run on lower levels like medium, so you can do some experiments on your system, but if you run into instability like random reboots or getting way high errors, pumping LLC up to high usually fixes it. So just avoid turbo extreme or ultra extreme because those push voltage way too far and basically undo the whole point of our tweaking. Alright, with that clear, I want to share a quick tip for anyone on a Gigabyte board. If you head over to the System Info tab, you can change the theme here. Since mine is the ICE model, it keeps with this gorgeous white theme. But if you prefer a black one, there is that too. Also, if you've been seeing on the Q code display, just the code 80, you are not alone. By default, it's like this, but you can customize it to show CPU temp, PCH, system, or disable it entirely. It took me some time to find this option. I personally like to have the CPU temp showing on it. So with that said, that's the BIOS setup I'm running. Now let's head back into XTU and finally check what the Advanced Tuning tab has. First, I would like to see what the CPU runs at with Intel default settings straight from BIOS before I show my tuned profiles. On the default Intel Performance BIOS profile, here is what we get. The two preferred cores, which are 0 and 2, runs at 55, other P cores at 54 when lightly loaded. With the 3 or more P cores active, the ratio drops to 52. As for E cores, all of them run at 46. In the processor tab, we see PL1 and PL2, both set to 250 watts. For ICC Max to 347 amps. Now in the cache tab, the ratio is set to 38. That's basically the ring pass speed. It helps move data between cores and memory. And finally, in the other tab, the system agent ratio is 32, and that's the fabric frequency, which links the CPU to the memory controller and PCIe devices. Both of these matter for stability and memory performance. We'll tweak them more carefully because any miss could trigger a very huge instability and random reboots. So I recommend first that you do the core tuning and then move on to the cache and the system agent tweaks. So when I run the default profile in OCCT with AVX 512, package power shot up to around 244 watts. Temps quickly climbed into the high 80s, and within a minute or two, some cores hit 90 degrees, and power limit throttling keep kicking in. Basically, at stock, the CPU performs okay but runs hot and inefficient. This is why undervolting makes such a big difference. And also, if you have noticed here in the profile section, XTU has its own default profile. Somehow it's different from the BIOS one I got. For example, it sets all P cores, even if 8 are active, to a 54 ratio. But somehow it makes even the fast cores cap at 54. So even when one active core, it's 5.4 GHz. It also changes the E cores to all 48 instead of 47 as the BIOS Intel default performance profile. But oddly enough, it has the PL1 at just 200 watts and PL2 at 225 watts, so pretty low. Other than this, there are no changes. On the XTU benchmark, it gets 12,651 marks. Again, if we run it in OCCT, we immediately see power limit throttling, while temps are lower, but that's only because the power limit has been capped to 200 watts for PL1. There is still zero undervolting happening here. Basically, just cut clocks and power to stay cooler, rather than actually improving efficiency. So for that, I created those 3 undervolting profiles in XTU that we'll finally get to see now. We have undervolt / high clocks, basically a light undervolt but with higher clocks. UV, a solid undervolt profile that delivers significantly cooler temps while still holding onto really decent clocks. And last but not the least, the super UV. That's the most aggressive undervolt, giving the best temps and efficiency while keeping the stability and the highest clocks possible too. It took me a whole week of testing to dial in these profiles, pushing for the highest possible clocks while keeping them fully stable. So if you find this guide useful, I'd really appreciate if you subscribe to the channel. It helps a ton and keeps me motivated to keep bringing you more content like this. So up first, we'll start with UV / high clocks profile. As I said, this one is designed to push clocks as high as possible while still applying a light undervolt. For voltage offset, as you can see, it's negative 0.060 volt. For P cores, we have the 2 fastest cores still at 55, others at 54. For 3 or more active P cores, I bumped ratios from 52 to 53. I also took advantage of Intel's thermal velocity boost, basically TVP, which gives you extra clock speed when the CPU is cool and then scales it back as temps rise. In my case, 83 degrees Celsius, it drops 1 ratio, and when the CPU gets to 90 degrees, it drops by 2. This way you get higher clocks when there is a thermal headroom, and lower ratios when things heat up. You can also customize how it behaves, for example setting different values depending on whether just one core is active or if multiple cores are. Now in the E cores, they have been raised from 46 to 47. I've also increased cache ratio from 38 to 40. As for system agent fabric, increased from 32 to 35. I also made sure to test stability a lot before doing all of those ones, like the cache and the system agent. You can see all of the changes in summary in this side panel, which shows the boot values versus the proposed changes I'm doing. In XTU benchmark, this profile scored higher than previous ones, over 13,000, but in heavy stress tests like OCCT, temps were still high, upper 80s and even to 90, and power limit throttling appeared. So while this profile gives the best raw clocks, like you see on AVX, it's above 5 GHz, it's not the most efficient one. I consider it more of an experimental pushing it profile, but we can also fix it by reducing the AVX ratio in the processor tab in XTU by around 5. You can now see how the power consumption has dropped by around 30 watts, making it slower in clocks but cooler and with less power draw. But still, this one doesn't feel like my finest work. We will get to the second profile, the Undervolt one. Here is what I said here. Voltage mode, I had to change it from adaptive to static. The reason is, with adaptive, it wouldn't let me apply a negative voltage offset at those higher clocks. It would only work if I dramatically reduce the frequencies. Setting it to static makes the undervolt stick properly. Core voltage is negative 0.165 volt. So you see this time we went significantly higher than the previous profile, by around 100 millivolt. For P cores, the two fastest cores are set at 54 and the others at 50. With up to 2 active cores, it runs at 53. But when 3 or more cores are active, it drops to 50. And no thermal velocity boost here, since the CPU already runs significantly cooler with this setup. As for E cores, all of them could peak to 45. With 1 to 2 active, they run at 45. With 3 to 11 active, they are at 44. And with all 12 E cores active, they max at 43. As for cache ratio, again it's the same, 40, as well as the system agent fabric at 35. Power limits for PL1, it's 225 watt. As for PL2, it's 230 watt. Now running XTU benchmark, we get 12,163, slightly lower than the default, but look at the OCCT FBX 512 stress test. Temps max out now at 77 to 78, with package power consumption around 204 watt. No power limit throttling or current limit throttling anymore, and the clocks are super stable. Like you see, it's 4938 MHz, pretty high stuff. Temps are way lower, efficiency is massively better, and performance is basically the same as default high performance. But if that wasn't enough for you, let's check out the Super UV. This is my most aggressive Undervolt profile and honestly my favorite one. Here is what I said here. Again, voltage mode set to static instead of adaptive, as it won't let me set that much of a negative offset with those high clocks. A whopping negative 0.200 volt. Imagine this much of an offset. For the two fast P cores, they peak at 53, others at 50. With 8 cores active, they drop to 49. As for E cores, same structure as the profile 2, 45 with 1 to 2 active cores, 44 with 3 to 11 active, and 43 with all 12 E cores active. As for cache ratio, it's the same 40 and system agent to 35. Finally, for power limits, for PL1, it's 215 watt and PL2 to 225 watt. In XTU benchmark, we got this time 12,215 mark. But now take a look at the OCCT stress test. Temps dropped by further 5 degrees, ranging around 72 to 74 degrees Celsius, with package power around 193 watt. So a drop from the previous Undervolt by around 10 watt while still having a good frequency. No power throttling at all. For me, this profile is the sweet spot. You lose virtually nothing in performance while temps are reduced by around 15 degrees in the heaviest workload compared to default. Power draw is down by around 50 watt and stability is still excellent. Those are the 3 undervolt profiles I built. UV and high clocks if you want to push higher clocks while still having some undervolt, UV for balanced efficiency, and Super UV if you want the coolest and most efficient setup with almost no performance loss. It's very satisfying to see how temps go down as we gradually switch between them. Some tips I'd like to share with you. In advanced tuning in XTU, you can shift select multiple cores to control more than one at once for voltage ratios, etc. Or control left mouse click to select one by one. It's pretty straightforward and self-explanatory tool. And once you are happy with the changes, press the apply button and you can later save the profile for comparing and defining different ones depending on the scenario. Alright guys, so in case you would like now to pick the profile to BIOS, I'll show you how I transferred those settings directly into it. This way, you won't need XTU at all. You can uninstall it altogether if you want to. The Undervolt will be baked into the system as a firmware level. So let's see how I did it on mine. So on BIOS, I created a custom profile to replicate the Super UV settings from XTU. Here is what I did. V-Core voltage mode, I changed it from auto to override. Don't set adaptive because it can block high undervolt at still high ratios. So I've set the V-Core offset to negative 0.200 volt. Cache ratio increased from 38 to 40 for a small bump, just like in XTU. That was the most stable for me at default voltage I got here for it. So it depends on your board. System agent set to 35. That also depends on your board. So make sure that you do it carefully. In the advanced CPU settings, V-Core ratio, the fastest 2 cores can peak at 53, others at 50, and 49 when all 8 cores are active. E-cores ratio, 45 when we have 1 to 2 active cores, 44 from 3 to 11 cores, and finally 43 with all 12 active E-cores. As for turbo power limits, PL1 to 215 watt, PL2 to 225 watt. Now again, I have here for IA, AC/DC load line, they are still both set to 76 instead of the default 78. Now we are back to the V-Core and VRM load line settings, same as we had them before as well. Performance on IA, AC, DC load line, and high on load line calibration level and current level protection. With just these settings, the BIOS profile behaved exactly like the Super UV profile in XTU. I need to note an important thing. In case you decide to transfer those settings to BIOS, before you do it, make sure you toggle off Restore Tuning after reboot in XTU. Like if you have the Super UV profiles active on XTU while having the same settings on BIOS, it may cause some issues. Also, you can see that if I have undervolt protection turned on after I set them in BIOS, they still work. But now in XTU, I can't reduce voltage below what it booted with. It actually makes sense. So if you set them in BIOS, you can enable undervolt protection freely if you want to. And also in case you set it this way in BIOS and get in Windows instead negative 0.199 instead of 200, that's totally normal. You can just reduce the offset in BIOS by another single step so it reads as negative 0.200 in Windows. It's just due to PCLK and how the voltage offset round internally. Usually it's not exactly 100 MHz, but like 99 point something. You can confirm it has been set in XTU as well as in hardware info in the voltage offset, as you can see here. Also, I want to show, here you can see in OCCT when the load line calibration is on high value. While if I set it to ultra extreme, you can see temps get a bit higher with more power draw. Sure, it could be more stable, but I don't recommend it as it's going to overburden the VRM and CPU, and the motherboard as well. Always aim for up to high load line calibration like upper medium or so, but not much more. I recommend you try different setups. For me, a C/DC load line on performance, as well as a V-core and current limit protection load line calibration both on high is the sweet spot. It may work with modes like medium, but for max stability, I'd rather keep it this way for peace of mind. Now in XTU in the Profiles tab, you can also import and export profiles. So in this way, I exported the 3 profiles I made, and you can download them from the description and pinned comment of this video if you would like to import them directly into XTU and try them out for yourself. But make sure you also set the things we talked about in BIOS as well to avoid issues and instability, especially the load line calibration and undervolt protection. So hopefully this way it can work out well. And of course, I didn't make a guide without some benchmarks to fortify it. So let's look at them now to see the difference in all the setups we have tried. First, I've run Cinebench R23. For the default one, Intel Default Settings Performance in BIOS, we got 36,195 in multi-core. The next 3 are our profiles. Undervolt and High Clock Profile got 36,855. The Undervolt Profile went a bit down to 34,370. And finally, the Super Undervolt 34,107. So we could say the trade-off was around 2,000 points from the Undervolt/High Clocks to Super Undervolt. Now as for the single core scores, default, Undervolt/High Clocks scored the exact same 2,324. For Undervolt and Super Undervolt, it went down by around 100. Now here is the cool stuff. On default, our max voltage reach is 1.324 volt. On High Clocks plus Undervolt, it's 1.269 volt. On Undervolt, it's 1.211 volt. And would you look at that? The Super Undervolt maxed at just 1.176 volt in Cinebench. That's some huge difference. For P-Cores ratios, 5.5 GHz for both default and Undervolt/High Clocks, 5.3 GHz for Undervolt and Super Undervolt. As for E-Cores, 4.6 on default, 4.7 on Undervolt/High Clocks Profile, 4.5 GHz for Undervolt and Super Undervolt. As for the max recorded CPU package temp, 83 degrees Celsius for default as well as Undervolt/High Clocks Profile. It went down to 76 degrees on Undervolt, so by around 7 degrees cooler. And finally with Super Undervolt, it maxed only at 62 degrees Celsius, a massive 20 degrees difference from the default one. CPU package max power consumption, 231 watt on default, 224 watt on Undervolt/High Clocks Profile, 192 watt for Undervolt, and only 172 watt for Super Undervolt. So imagine the difference in power drop, an exact 51 watt less from default. I must say, I'm really proud of the Super Undervolt Profile. It's really magical how cool it runs now. Let's now unfold more tests that I've got. Here I am in OCCT again, comparing them all at once in AVX 512 running the Xtreme stress test mode to get a panoramic view. You can see the difference in temp from default to Super Undervolt. It's 20 degrees lower, power draw is roughly 50 watt less, and voltage is lower as well. So this way it's going also to improve the longevity of the CPU over time. Of course, we shouldn't get too carried away until we can just confirm full stability. So I've run all those profiles through some rigorous tests. For example, here we have the All-Star Super Undervolt Profile in OCCT for roughly 30 minutes, and it passed with the flying colors. Now don't think for a minute that I only ran OCCT on AVX 512. I also did so with SSE workload, and it worked well as well. No overheating, no power limit caps, fully stable, running it for 30 minutes. Temps didn't go above 74 degrees Celsius. Sure, we can't rely on just OCCT for stress test, even though it's solid, but doing variation in test is important because each one trains the CPU differently. For example, AIDA64 stress test isn't as heavy but still very useful to test stability. So I ran it for hours and hours on the Super UV profile and it was rock solid. Temps didn't go above 70 degrees Celsius with max power consumption at 153 watts and power current at 119 amps. So all good here. Both OCCT and AIDA64 will be installed for free, so you don't need any kind of license. Surely you can't call it a day without trying out some games too. So let's check them out. I benchmarked 7 games for default and the 3 manual profiles we built. Please have a look. Cyberpunk 2077, you can see the difference in power draw from default Super Undervolt. We shed off around 20 to 25 watts and dropped roughly 7 degrees Celsius in temps without compromising performance at all. FPS was basically identical across all setups. The Undervolt/high clocks profile had the highest clock, but performance wasn't dramatically different, like just around 1 to 3 FPS difference on average. But things could depend also on game. Like Black Myth Wukong, here's the difference in power consumption and temps wasn't too vast, about 5 to 10 watts. Still, Super Undervolt always had the lowest temps and power consumption. And performance-wise, the difference was minimal, maybe around 3 FPS. Next, we have Age of Empires Mythology Retold. This game consumed about the same in all setups, no big difference. Undervolt/high clock profile scored the best, but all profiles were very tight in terms of performance. Next is Dirt 5. Here I saw some significant power draw reduction and temp drops on Undervolt and Super Undervolt profiles, about 10 watt less. On Undervolt/high clocks profile, while it was around 93 watt, on Super Undervolt it was 78 watt. Performance impact was pretty tiny. Next I tried Rainbow Six Siege. Again, power and temps drop on Undervolt and Super Undervolt profiles with basically identical performance. Now a good CPU demanding title is Assassin's Creed Mirage. Here we saw 8 to 10 watt drop in power and about 5 degrees lower temps. Surprisingly, the Super Undervolt actually topped all the other configs. So you can see higher clocks aren't always better. In this case, like a lower clock of 400 MHz delivered more consistent performance. Finally, we have Counter-Strike 2. Since FPS here gets really high, difference could show clearly. Undervolt/high clock profile scored 682 FPS. Default 659, Undervolt 656, and finally Super Undervolt 646. Like at the end of the day, we didn't lose much. Like considering we are already at 600 FPS, it's basically negligible, like around 2 to 3% difference. So with that said, those are the benchmarks I've done. So I would like to say in the end, undervolting the Intel Core Ultra 7 265K is absolutely worth it. You will save power, significantly drop temperatures, while having performance little affected negatively. For me, it feels like a pure joy, and it can actually be useful, especially if you are planning to use this CPU in a small form factor build like an ITX or M-ATX case with limited cooling. Even a light undervolt makes the whole system run cooler, like given that the CPU is going to generate less heat, even the surrounding components could benefit. And here in my case, my humble 240mm budget AIO is cooling this monster just fine without any hiccups. So if you have this CPU, I definitely recommend giving undervolting a try. Just be patient, test carefully, and don't push too far too quickly. You can try my profiles, they might work out for you, but also make sure that you also try to match the BIOS tweaks I showed earlier. Finally, I really hope this guide was useful for everyone. It honestly took me a full week of testing to dial in these profiles, undervolting while pushing for the highest possible clocks while keeping them fully stable. So if it was helpful, please give the video a like and subscribe to Techosaur. It really helps a ton and keeps me motivated to keep making more content like this and also improve my equipment and testing benches over time. And of course, if you have any questions or run into issues as you try to apply those tweaks, just drop a comment or connect over Techosaur Discord server. I'll do my best to help out. And as always, Thanks for watching, take care, and I'll catch you in the next one.